forgot. I'm doing a video today. How are you guys? Today we're going to do the pre-lab for the determining the ideal gas constant. You learned about that on Friday, what the ideal gas constant is. Basically, it's at STP. If you take the volume divided by temperature, you end up with the or pressure times volume divided by temperature and the number of moles, you end up with the ideal gas constant. This allows you to do a whole lot of stuff, including stoichiometry, which I know you're excited to do. All right. So our beginning question is, what is the value of the ideal gas constant? All right. For our procedure, step 1, the ever popular goggles. Step 2, you're going to get a 400 milliliter beaker and fill it with tap water. Step 3, you're going to get a length of magnesium ribbon, and we are going to actually walk down to Miss Rice's room to use the extra special balance to find the mass. This is an analytical balance. It basically is a little box, and the balance pan is inside the box, and what you do is you put your object being balanced on and you slide the door shut, and then air currents can't mess with it. So instead of reading to 0.01, we can go to 0.001. So we're just that much more accurate. Okay? So we'll be massing the magnesium. After we've gone down there and done that, step 4, you'll come back in. You're going to get a piece of once again, I should have changed this. Step 4 is already done for you. Step 4 looks like this. Okay, so step 4 has been done for you. You have this whole apparatus, the stopper. Instead of looking like that, though, you guys are going to have a much shorter piece of copper wire that just comes down and sticks out like that. And for step 5, you're going to take your magnesium ribbon and fold it over. So you get the magnesium ribbon folded onto the stopper, the copper wire in the stopper. Step 6, already been done. Step 7, you're going to get a eudiometer. The eudiometer is a giant test tube, and it has markings on the side, and we want to fill that up with 2 molar hydrochloric acid. We only want to fill it to the 15 milliliter line, though. Okay, you don't need more than that. If it's not exact, that's okay, because this is the excess. This is not going to be used up in the equation, so it doesn't matter. 15, 14, 16, all okay. That's 7 and 8. Not numbered well. Step 9. Then you're going to add deionized water. Okay, so here's your tube. You're going to fill it up with the deionized water. And then step 10, you're going to add the stopper into the test tube. And when you do that, it'll overflow a little bit. That's okay. Step 11, you're going to put your thumb over the top of the test tube. Now, this is not a eudiometer. This is a test tube. This stopper is about the size, maybe a little bit smaller, of what we're going to be doing. What you'll do is you'll put your thumb over the top. Keep in mind there's a hole in there with liquid. You're going to flip it upside down, and then you have to lower it down into your beaker until your thumb is under the water of the beaker, and then you take your thumb off and pull your hand out. Okay? I'll show you that in class. So for step 11, basically we're going to invert without losing any, without letting any air inside. We're going to invert our eudiometer full of water and hydrochloric acid into our 400 milliliter beaker beaker of water. And now what's going to happen is the hydrochloric acid it was down here, right? It was at the top bottom. So it's going to be able to it's going to start to come down, and the water will start to go up, and you actually get to see something really cool. It's called Schlieren. It's when you have two different densities mixing, and it's a really cool effect. So I hope you all enjoy it. The College Chem kids loved it. They thought it was awesome. So you can look for the Schlieren going on. And what's happening, as the acid gets down here to the magnesium, it will begin to react and bubble. And the reaction that you're going to be seeing will be producing hydrogen gas. All right. Step 12. Record evidence of what's going on. All right, so tell me, do you feel any warmth coming off of it, exothermic or endothermic? Do you see bubbles? What do you see? I want you to record that into your data table. We're going to allow it to stand until the bubbles stop. At that point, then we will be moving it to the sink, and I will show you what we do next, but that last step will have a large graduated cylinder, and you're basically going to have to put your thumb over the end again and move it from your beaker to the graduated cylinder, and we want to equalize out our volume, and we'll talk about that in class more because that has to do with our volume and our pressure. All right, so that is all for today except for the fun of a data table. This is the data table you're going to use. You are going to need to record it says length of the magnesium ribbon. You guys are just going to have mass in grams. It says the volume of the hydrogen collected. We'll talk about that. The air pressure, I'll look it up on the WeatherBug site because Olathe North has a WeatherBug weather station. And so I'll get our actual air pressure for today. And then any observations. Post-lab calculations we'll do together on Monday. And there you go. Thank you very much.